Hi guys, welcome back to my channel guys. Look, today I'm going to teach you a new question based on a titration. In that question, we are going to crack the percentage purity of impure substances by using a titration technique. Why I have chosen this question? Because I have seen this type of question in many past papers. So guys, I think you have only 3-4 weeks left for your final examination. Please focus on your examination. Don't waste your time. That's the best time to do more revision. And after this week, you have half term coming up. So utilize that time and do more revision on that. And if you have any question regarding the chemistry, or any question from the past paper, please get back to me and you can text me or email me your question on my channel. Okay, let's see this question. Yeah, look at that. This is 2.5 gram of impure sodium carbonate was dissolved in pure water. Yeah, 2.5 gram of impure sodium hydrogen carbonate was dissolved in pure water. Don't get confused with the pure water. This is deionized water and the volume made up to 250. Let's start the question. So we have 2.5 gram. You can weigh the 2.5 gram of sodium hydrogen carbonate, which is impure NaHCO3, dissolved in pure water or deionized water. Actually, that's the deionized water. There's no pure water. So, and transfer that into a volumetric flask and made a solution up to 250. Okay, that's our first step. You know that after that, you pipette out 25 centimeter cube into the conical flask and titrate that 25 centimeter cube of this solution with sulfuric acid. Sulfuric acid we have to fill in a burette. Okay, I know this look very lengthy question. It's just wording, guys. When you crack down in that way, it's easy to solve this question. I always told my student, try to visualize that by a small drawing. So that will definitely help you to crack this question. Look at that, it's so simple. We don't want all these worded information. We just need a few information. That's the 2.5 gram of impure sodium hydrogen carbonate. We know that sodium hydrogen carbonate is not pure in terms of this question. My first question, my question is that can we use 2.5 gram of impure sodium hydrogen carbonate to work out its mole? Anyone, guys? No, we can't use 2.5 gram to work out its mole. We know that this is impure. I don't know how much impurity is there with sodium hydrogen carbonate. To figure out its actual mass, we are using a titration technique. With the help of a titration technique, you can figure out the mass of the pure sodium hydrogen carbonate. Okay, so I showed you we are using sulfuric acid to figure out the moles of sodium hydrogen carbonate. Look at that. We don't need all these worded question. We just need information, this information. If you don't mind, can I rub the board? Yeah. So I already explained a little bit here. So we can jump over the calculation. So let me write few things here. What are the few things we want? Impure mass, which is 2.5 gram, and we made a solution up to 250. We want a volume of sulfuric acid, which is here, and a conc of sulfuric acid. That's it. An equation between sodium hydrogen carbonate and sulfuric acid. Okay, guys. This is the impure mass of sodium hydrogen carbonate and the conc of sulfuric acid. I'm going to write one more time. Conc of sulfuric acid and the volume of the sulfuric acid, what we got at the end of the titration. Okay, look at the vol and conc. So the first step is to work out the mole of the sulfuric acid, which is mole equals to C conc of sulfuric acid time volume of the sulfuric acid divided by 1000. Okay, 0.05 time 28.3 divided by 1000. Okay, look at that. When you do the calculation, you will get this many moles of sulfuric acid. To work out the mole of sodium hydrogen carbonate, I have to write its balanced chemical equation. Okay, so conc, we know conc of sulfuric acid and the volume of the sulfuric acid. If you don't mind, can I rep the question? This part only, yeah. So I have all the information. We don't need this one. Guys, always this is the easy way. When the question is very lengthy, break down into simple way, or try to visualize by using little drawing. Let's see. So a balanced chemical equation. Look at the balanced chemical equation between the sodium hydrogen carbonate and sulfuric acid. Sodium hydrogen carbonate plus sulfuric acid. When a carbonate react with any carbonate react with sulfuric, react with acid, you will get salt, Na2SO4, sodium sulfate, plus carbon dioxide gas, plus water. So look at that. How many sodium? 2 sodium times by 2. What's the molar ratio? 1:2. So you got this mole of sulfuric acid. To get the mole of pure NaHCO3, you have to times by 2. Mole of NaHCO3 equals to 1.415 into 10 to the power of minus 3 times by 2. Okay. Now look at that. Sorry guys. Look at that. Okay. Now 2.83 into 10 to the power of minus 3 is the mole of Na2CO3, NaHCO3 for 25. We titrated 25 centimeter cube of sodium carbonate. But initially, we made a solution up to 250. So work out the mole for 250. How can we work out the mole? Times by 10. So moles of NaHCO3 for 250 centimeter cube equals to 2.83 into 10 to the power of minus 3 times by 10. Okay. Now look at that one. So how much is that? 2.83 into 10 to the power of minus 2. Okay. We got the mole of pure NaHCO3. Now, can we use this mole to work out the mass of pure NaHCO3? Yes, why not? Mass of, this is the mass of the impure. I still did not remove clear that one, so that we can use this value to figure out its percentage purity. So mass of the pure sodium. Now look at that. That's the mole of pure NaHCO3 for 250. Now, mass of pure NaHCO3. Look at that one. Mass of pure NaHCO3 mole time its MR. How much is the mole? 2.83 into 10 to the power of minus 2 time, work out the MR of sodium hydrogen carbonate, 23 plus 1 plus 12 plus 48. So it's equals to 84. Yeah. Now, when you time this to, see what you will get. You will get the mass of pure sodium hydrogen carbonate. Let's the mass of the pure sodium hydrogen carbonate. Yeah, you use your calculator, which is nothing but 2.83 into 10 to the power of minus 2 times 84, which is equals to 2.37. That's the mass of pure sodium hydrogen carbonate. Look at that. Mass of the pure sodium hydrogen carbonate, mole time its MR, which is 2.37 gram. That's the mass of pure one. And look at the mass of impure one. So what's the formula to work out the percentage purity? Easy one. Percentage purity equals to mass of pure divided by mass of impure time its 100. Always percentage mean you have to times by 100, which is nothing but 2.37 gram divided by 2.50 gram. Guys, impure is always bigger than your pure one, obviously, times by 100. When you work it out, you can use your calculator. The answer is 95.1 something percent. So this is the way you can figure out percentage purity of any chemical substance. We can use a titration technique to answer this type of question. So thanks for watching this video, guys. I will come again. Look at this question. It's a type of hydrated salt. I've seen this type of question in many past paper, guys. Look, they will ask you to work out the number of mole of water molecule attached to hydrated salt. First of all, normally we have two types of salt: hydrated salt and anhydrous salt. Anhydrous salt has no water molecule attached to it. And hydrated salts are those to which some of the water molecule are attached as the integral part of the salt, so that its MR increases. This is called hydrated salt, and hydrated salts have a definite shape. That's why we call them as a crystalline salt. Now, the mass of the hydrated salt is given to you, which is sodium carbonate, and that sodium carbonate, hydrated one, we dissolve in water. Like, take little amount of hydrated salt. How much hydrated salt is given to us? Look at 2.86. We take 2.86 gram and make a solution up to 250. and made a solution up to 250. Okay, that's the solution of only sodium carbonate. Why, sir? When you dissolve the hydrated salt, this part, which is the integral part of the sodium carbonate, also dissolve and form a water molecule. So that's the solution of only Na2CO3. This solution we are titrating with known concentration of HCl. Yeah, so concentration of HCl is given, volume of HCl is given. So the first step is to solve this question is that you have to work out the number of moles of acid given. So guys, if you don't mind, because I'm really sorry, I don't have enough space, can I rub this part here, the top part? I know how much salt we have taken, 2.86 gram. Okay then. And you have to work out the number of moles of HCl used. Work out the number of moles of HCl used. Look at that. Mole of HCl, mole equals to C times V over 1000. Okay. Look at that. What's the conc of HCl is given in the question? 0.1. So 0.1 times 20 divided by 1000. So this cancel. 2 into 10 to the power of minus 3 mole of HCl. Okay. To work out the mole of only sodium carbonate, we have to write the balanced chemical equation between the sodium carbonate and HCl. Balanced chemical equation between the sodium carbonate and HCl. Okay. Balanced chemical equation between the sodium carbonate and HCl. Okay. Look at that. Any carbonate, when react with acid, we will get carbon dioxide, salt, and water. React with acid, we are getting NaCl plus H2O plus carbon dioxide gas coming out. How many sodium we use here? 2. And there's 1 sodium times by 2. How many chlorine? 2 chlorine, so times by 2. Look at the molar ratio, 1:2. We got the mole of sodium, we got the mole of HCl. To get the mole of sodium carbonate, we have to divide this by 2. Now, the moles of only Na2CO3 equals to, look at that, can I divide this mole by 2? 2 into 10 to the power of minus 3 is the mole of HCl divided by 2. 1 into 10 to the power of minus 3. Whatever the mole you got, this is the mole for 25 centimeter cube. Because we, no doubt we made a solution up to 250, but we only used 25 centimeter cube and titrated with HCl. So these are the moles of sodium carbonate for 25 centimeter cube. Mole of Na2CO3 for 250 centimeter cube. So you have to times by 10. 1 into 10 to the power of minus 3 times by 10, which is equals to 1 into 10 to the power of minus 2. With that mole, what can we do next? With that mole, can we work out the mass of only Na2CO3? Mass of sodium carbonate. Yep. Can we work out the mass of sodium carbonate? Yes, why not? So mass equals to mole time. It's Mr. Look at that. Sodium carbonate and Mr, Na2CO3. CO3 23 times 2 plus 12 plus 48, which is equals to 106. So mass of only Na2CO3 equals to mole time its MR. Mole 106 times 1 into 10 to the power of minus 2, 1.06 gram. We got the mass of only Na2CO3, and we know the mass of hydrated salt. What's the mass of hydrated salt? Mass of hydrated salt, which is given in the question, hydrated salt Na2CO3 NH2O equals to 2.86. Agree? Yeah. Now I want to rub it. See guys, I'm keep on telling, I have seen this type of question or similar to that in many past paper. Paper one for OCR, Edexcel, AQA. Okay, now look at that. Mass of hydrated Na2CO3 NH2O equals to 2.86 gram, which is given in the question, and we just work out the mass of the pure Na2CO3. Mass of only Na2CO3 equals to 1.06. If you subtract that two masses, we will get the mass of NH2O. Mass of NH2O equals to 1.8. Work out. You'll get 1.80, yeah, 1.8 gram. That's the mass of NH2O. After that, how can we crack a number of molecules of water attached? Okay, use the technique of finding empirical formula. So you have to work out the molar ratio of sodium carbonate and water molecule. Okay, look at that. Masses, we have masses, so we will work out the molar ratio of sodium carbonate and NH2. So moles, look at that. We have Na2CO3 versus NH2O. The masses is given, mass over its MR. No, we found out the mass of sodium carbonate. We worked out the mass of sodium carbonate, and its MR equals to 106. Work out its molar ratio. We worked out the mass of water, 1.8, and AR of MR of water is 18. How's that? 1 times 2 hydrogen plus 16. Okay, work out. Now look at that. This is 0.01. This is not 0.1. So what's the molar ratio of sodium carbonate and NH2O? 0.01 is 2, 0.1. Now use the technique of empirical formula. So divided these two numbers with the smallest number, that is 0.01 and 0.01. This is 1, this is 10. So what is the number of moles of water molecule attached? N equals to 10. That was our question. N equals to 10. Look at that. Very similar questions will come up in the redox titration also. Mainly redox titration is between ferrous sulfate and KMnO4. So hydrated ferrous sulfate will be given to you. In the hydrated ferrous sulfate, you have to work out the number of water molecule attached to ferrous sulfate. So by this way, you can easily work out how many water molecule attached to a particular salt, which make this salt as hydrated salt. Look at this question, guys. This question is based on back titration. First of all, how can we use back titration to figure out the percentage purity of impure substances? I will explain you. In a back titration, you will get impure substances or the alloys. With the help of the back titration, you can figure out the mass of the pure substances present in impure substances. This is a type of that question. Or sometime they will give you alloy and you have to figure out the percentage of a metal in a respective alloy, like copper alloy. You have to work out the amount of the copper in bronze. So see that question. I like this question. This is my one of the favorite questions. I have seen this question in many past paper. That question comes in AQA, OCR, AQA, OCR, Edexcel in many past paper. Okay. Here, impure limestone is given to you, and some mass of limestone is given to you. Calcium carbonate plus some impurities with the pure form of calcium carbonate is called limestone. Limestone is nothing but the chalk. You know the white chalk teacher used to write on the blackboard. So we have to work out the amount of calcium carbonate present in the given limestone. I'm just explaining you. You can read that question. Here, in this type of back titration, we are using excess of HCl. When you use the excess of HCl, some amount of HCl, look at that, HCl is in excess. This HCl is in excess. First, we crush the limestone into small pieces, and that limestone we are going to react with HCl. When you add HCl to the crushed limestone, you will definitely get carbon dioxide gas. So after that, you have to wait. Look at the question. Was left until all the bubbling stop. Bubbling of carbon dioxide stop. So look at here. So you crush the limestone into pieces. Then that's my limestone. And we are adding excess HCl. When you add HCl to the limestone, you have a reaction with bubbling of the carbon dioxide gas. I'm writing the reaction. Sorry, I don't want to write the reaction because that's a limestone. This is not the pure form of calcium carbonate. Anyway, you have to wait till all the bubbles of carbon dioxide cease down and transfer that into a volumetric flask and made a solution up to 250. That was given in the question and was then made up to 250. This 250 centimeter cube of a solution, then we will titrate with sodium hydroxide. Pip it out, 25 centimeter cube, and titrate it with sodium hydroxide. Why we are titrating this solution with the sodium hydroxide? Anyone? What's the purpose of using sodium hydroxide? Look at here. Sodium hydroxide of a concentration was added from the burette. 30 centimeter cube of sodium hydroxide were needed. Anyone? What's the purpose of sodium hydroxide used here? See, I told you HCl is in excess. So look at that. CaCO3 plus 2HCl, we are getting calcium chloride, CaCl2 plus CO2, okay, plus water molecule plus H2O. This hydrochloric acid is in excess. So the hydrochloric acid, which is in excess, some part of the hydrochloric acid react with calcium carbonate and some part left in the solution. To figure out the amount of the HCl which is left in the solution, we will titrate with the sodium hydroxide. That's the question, guys. So the amount of the HCl which is unused, it means left out in the solution, will titrate it with sodium hydroxide. That is why this is called back titration. Okay, I know the mass. What mass, if you don't mind, can I rub? The mass of the limestone is 1.25. If you don't mind, can I rub the question? Yeah. Okay. Is this question clear to you? So look at that. We are using excess of HCl. A concentration of HCl is given, and the volume of HCl is given. So conc of HCl is 1.0 and volume is 50. So with that, you can figure out the number of moles of HCl used initially. So moles of HCl used initially, mole of HCl. Mole of HCl equals to C times V over 1000. What's the C? 1 into 50 divided by 1000. How much? 5 into 10 to the power of minus 2 moles. So that's the initial moles of the HCl used. Okay. Now, some of the HCl reacted with the sodium carbonate. Some of the HCl reacted with the calcium carbonate, and all the impurities which is present in the limestone settle down in the solution. Because in that question, it is titrated with HCl. So all the impurities dissolve. Now we have to write one more equation to figure out the amount of HCl left out in the solution as a mixture. Now, with the help of the conc of NaOH and the volume of NaOH, we can also find out the number of moles of sodium hydroxide. Moles of sodium hydroxide, mole of NaOH equals to C times V over 1000, which is 0.1 times 30 divided by 1000. So look at that. This cancel, 3 into 10 to the power of minus 3 moles of NaOH. We got 3 into 10 to the power of minus 3 moles of NaOH. Number of moles of sodium hydroxide, 3 into 10 to the power of minus 3. So to work out the mole of HCl, which is unused, we have to write one more balanced form of a chemical equation. That's why we name this titration as a back titration. So number of moles of HCl which is left out. HCl plus NaOH, simple acid-base reaction. We will get salt plus water. NaCl plus H2O. Okay. Now, this is the mole of NaOH. Look at the molar ratio, 1:1. So the same mole for HCl. The moles for the HCl, 3 into 10 to the power of minus 3. That's the moles of HCl left out in this solution. 3 into 10 to the power of minus 3 moles of HCl unused or left out into the solution. But this is the mole for 25, and we made a solution up to 250. So work out the moles of HCl for 250 moles of HCl for 25 2, that's for 25. For 250 centimeter cube, 3 into 10 to the power of minus 3 times by 10. That's the mole of HCl for 250 centimeter cube. Now, that's the mole of HCl left out in this solution. And we know the initial mole. Guys, these are the initial mole of the HCl. Okay. Now, so 3 into 10 to the power of minus 2, that's the mole of HCl left out in the solution. So how much mole of HCl used to react with calcium carbonate? Look at that. Initial minus unused. 5 into 10 to the power of minus 2, that's the initial mole of HCl, minus 3 into 10 to the power of minus 2, that's the number of moles of HCl left in the solution. How much left out? So 2 into 10 to the power of minus 2 moles of the HCl actually reacted with calcium carbonate. Okay. I rub the equation between the calcium carbonate and HCl. I will write it again, don't worry. Sorry for repeatedly rubbing the board because I don't have enough space. Now look at that. CaCO3 plus 2HCl will give CaCl2 plus water plus carbon dioxide gas. What's the molar ratio? 2:1. So we got the number of moles of HCl reacted with calcium carbonate, which is 2 into 10 to the power of minus 2. Okay, to work out the number of moles of calcium carbonate, we have to divide by 2 because it's a 1:2 molar ratio. So moles of CaCO3, pure form of CaCO3, that is only reacted. Moles of CaCO3 equals to 2 into 10 to the power of minus 2 divided by 2, i.e. 1 into 10 to the power of minus 2. This is the mole of pure form of calcium carbonate. With that mole, can we work out its mass? Yes, why not? We can work out the mass of pure CaCO3. Mass of pure CaCO3. Mole time, it's Mr. Mole time, it's Mr. Okay. What is the Mr of calcium carbonate? Take calcium as 40. Ar of calcium is given in the periodic table as 40.1. I don't want to take 40.1. I just want to take 40 to get easy calculation. Okay. Look at the Mr of CaCO3. CaCO3 OE plus 12 plus 48 equals to 100. So mass of pure CaCO3 equals to mole not 1 into 100, which is equals to 1 gram. This is the mass of pure CaCO3. But when you just read the question one more time, a 1.25 gram of limestone is given, which is the impure form of CaCO3. So now we can work out the percentage purity of pure CaCO3. Okay. Now this is the mass of the pure CaCO3. Guys, always pure mass is less than the impure form. Look at the mass of the pure CaCO3, which is 1. Now percentage purity equals to mass of the pure, which is 100, mass of the pure calcium carbonate, which is 1 gram, and a mass of the impure calcium carbonate, which is limestone, that is given in the question, times by 100. Work out that. It's equals to 80%. That's your answer. So please go through this question for 1 or 2 times. If you did not understand, come back to me. I have done all the question that comes in amount of substances. This is my last video on the amount of substances. Soon I will start chemical bonding in my next video. So guys, if you have any question regarding with empirical formula or the titration, back titration, any kind of question, please come back to me or write your question in the comment box so that I can approach to you. Thanks for watching all my videos on amount of substances. Okay, I will see you soon.